Okay, and time t is equals to 0. Huh? And now the next thing is here, the next we have the angle phi. Whatever the angle phi, the phase angle, it is positive in nature. Okay, plus phi I'm adding to my instantaneous value. If E is equals to Em sin omega t plus phi, so angle phi is added means I'm going to start my waveform. I'm going to start from waveform from the zero reference line, from the reference line only, but it won't start at exactly at the origin. It will shift little bit above, like above the angle, whatever the angle they have given us, so the angle it will be shifted, and from here it is going to start. So whenever we have a positive phase angle, then my waveform it will start above the reference line. So this is my reference line, no, the time t is my reference line. So my angle, my phase angle, it will start above the reference line. Okay, and if my phase angle is negative in nature, if it is in negative in nature, then my phase angle it will be below. My phase angle it will be below, it will start from below. Now this concept you have understood from the previous class. Okay, now today we are going to study about the concept of phase difference. The concept of phase difference. Okay, now what is that phase difference is? Phase difference, see, the difference between two parameters, it can be identified only when you have two phase angles. Difference means I'm comparing one with the other one, one with the other one. Now I'm going to consider the two different phase angles. See, my first one I will take it as voltage. Okay, see, if you take any particular device now, both voltage and current, both it will be present. Now I'm going to indicate in a single graph. In a single graph, I'm going to indicate the voltage and the current phasor diagram. Current and the voltage phasor diagram. Okay. Now, if I consider the voltage, my phase angle, see, this equations they have given. Just by seeing this phase angle, can you just tell me what is the phase angle difference that it is given from the voltage or the current equation? Just by seeing the equation. What is my phase difference now? What is my phase angle phi?
0, ma'am.
Yes, it is 0. Exactly. Because so E is equals to Em sin omega t. I don't have phi here. If no phi means it is 0. So I can say that I have a 0 phase difference between current and voltage here. Current and voltage here. Now, if I want to write the diagram, for that, see, here is a particular diagram. Here is a particular diagram. What is that? My phase difference is 0. If my phase difference is 0 means, as you have studied just now, if my phase difference is 0, my what is a waveform, it will start from the origin exactly at 0 position. Yes, yes, because here I have drawn two waveforms. One it is for voltage and other one is for current. The one is for voltage and the other one is for current. See, whenever we take any kind of devices, no, why this current amplitude is less and why the voltage is maximum? We have one particular reason here. Whenever we go, no, the amplitude of voltage always it will be greater than the current. Greater than the current. I will just take a simple thing. Assume that I have given on supply. Okay, this is not there in your syllabus. Just to make you aware that why the voltage. Whenever we draw the waveforms, no, the voltage amplitude will be more. See, as soon as I say amplitude, you should know what is amplitude. It means that difference between from 0 to this point. So this is my amplitude. Okay, for voltage, it will be something like, if I consider Em, this Em will be greater than this Im. Em will be greater than this Im. Always the current amplitude, even though it is pi, even this pi, it will go, it will wind up with that pi only, and even it will go in this direction. But the amplitude of the current, it will be lesser compared to your Vm. Okay, what may be the reason here? What may be the reason? Can anyone just tell me what is the reason why the amplitude Em will be always greater than Im?
Due to resistance in the
Yes, exactly.
circuit.
It is because of the resistance which is present inside the circuit, right? So if I consider this is my voltage E, and if I want to run one particular device, assume that I have one fan here. I should run this fan. If I want to run this fan, this is nothing but my load, whatever the load. Okay, in place of load I have taken one fan, and this fan, it may be just because fan, it will run based on the inductive principle. The load I'm going to consider, it is an inductive load. So fans always, it will be inductive in nature. We can't use the resistive load, so we won't get the complete control on that particular device if it is a resistive load. Okay, suppose instead of that I can take any one DC motor. If I take a DC motor, it will be of resistive load. Okay, if that resistive load, that particular DC motor, if you want to run, means I will be using one internal resistance. I will be using one internal resistance, and I'm going to make a circuit, a complete circuit here. So whatever the voltage that is passing here, the voltage VE that is passing here, the same amount of voltage it will be flowing across the load. If you don't have any inductor or capacitor in the finger. Okay, if it is a purely resistive wave, if, or it may be, if it is a purely resistive circuit, then the whatever the voltage that I'm going to give here, the same amount of voltage that will be present across the load. So my, I can say that something like Vs is my supply voltage and VL is nothing but my load voltage. So Vs will be equal to VL, and there will be some what is that, a negligible drop of voltage will be there. As it is a negligible value, we are going to neglect that. We are not going to neglect. We are going to neglect that. Okay. So my supply voltage will be equal to the load voltage, but the current is not like that because we have a resistor here. What is the job of a resistor? Resistor always, it opposes a flow of charges, right? Or the current. So what happens? Whatever the voltage you are giving, the same amount of voltage, if it is flowing, the current, obviously the voltage, because of the resistance, you have a formula, V is equals to I into R. I into R. This R resistance, it will utilize some amount of charge carriers to overcome that, and then the current will be passed. So because of the same reason, the current always, it will be, whenever you draw the waveform for voltage and current in one phasor diagram, always the magnitude of the voltage, it should be greater than the current. Keep this in your mind. Don't draw equal waveforms for current and voltage. Getting my point? So the next thing is, we have just discussed now, even the voltage waveform and current waveform, both it is having zero phase angle. If zero phase angle means both the waveforms, so see, this is my voltage equation, voltage waveform, it will start from zero, and even the current also, it is starting from zero only, because the phase angle difference between voltage and current is zero. My angle phi is zero here. My angle phi is zero. And you can take different instants and you can draw the phasor diagram. What is that? This is the voltage and the current. Both it will be in the zero reference line. See, I'm indicating the bigger circle. A bigger circle, it is for voltage, and a smaller circle is nothing but for current. So they have given this is EM, that is maximum voltage, and this is current. Initially, my voltage will be zero. Voltage will be zero. As that angle varies, as a theta, it is going to vary. What happens? It will move in the anti-clockwise direction, and it will complete one particular cycle in one circle, right? And when it is going to get maximum, my voltage, what is that, my voltage and the current, both it is maximum at an angle theta is equals to 90 degree. Theta is equals to 90 degree. So you have a formula, E is equals to Em sin theta, sin omega t. That omega t, if I put it as 90 degrees, sin 90 is nothing but 1. So E will be equal to Em. So maximum voltage I'm going to get when theta is equals to 90 degree, or it may be theta is equals to pi by 2. So just in this concept, you know how to draw the circle. This concept you have studied in the previous class, and now I should concentrate only on the phase angle. So I don't have difference in the voltage and current. The phase angle difference, it is not there. Hence I am going to start both the waveforms exactly at the origin. Exactly at the origin. Okay, this is nothing but a zero phase difference. Zero phase difference. If they ask you to explain the concept of zero phase difference, yes, you have to take two equations. Two equations that may be for voltage and current. Okay, voltage and current, and always Em will be greater than Im. This is, it is known to you, and from this you can indicate that angle phi is zero. Angle phi is zero for both voltage and current. Hence it is a zero phase. Hence it is a zero phase difference. Hence it is a zero phase difference. So we are going to neglect that. We are going to neglect that. I don't know what is the problem. Even yesterday I have reinstalled this Adobe Reader in my laptop, but still it is showing. If I go back, it's showing with the empty screens. Getting my point? You have any confusion with that? Whatever till now, whatever I have explained you. Any confusions? If you understand the zero concept now, the next one is very simple. I'll go for the.
Ma'am,
Yeah.
ma'am, what if the 5 is not 0, ma'am? What will happen? Can you
That's what.
please
I'll come back to that. I'll come back to that. Whether if now you just have a concept of if phi is zero, that is zero phase difference. Now next I will come back. If phi angle phi is plus positive in nature, if angle phi is negative in nature, how the waveform it will be indicated. That I'm going. I'll come back to that. Okay. Just within one particular second, I'll come back. But I'm not able to open this. That's the problem. I have reinstalled yesterday, but still I'm getting this issue. What is that? Ah, okay. So this you have understood. The next thing we are going to concentrate. The next thing we are going to concentrate. Just now, one of the student asked me, what happens if angle phi is not zero? If it is not zero, okay. If it is not zero means, so I will consider the next one as I will consider the next as it is a lagging phase difference. Okay, lagging phase difference. Lagging phase difference means here we are going to consider in the lagging phase difference. I am going to consider the angle phi as minus phi. I will consider the angle phi as minus phi. Suppose I will just write down the equation first. I think in this particular book they have not given the equation. Okay, this is a waveform. This is a waveform, but I will write down the equation here. See, I will just consider for a lagging. My equation again, I'm writing the phasor diagram for two parameters. So one is voltage and other one is current. So my voltage equation is E is equals to Em sin omega t. Em sin omega t. Can anyone just tell me what is this angle for phi here? What is the angle for phi here?
0.
It is 0. So I will just indicate angle phi is 0 here, 0 degree. Means if it is 0 degree means this voltage equation from where it should start? It should start from origin, right? Just keep this in mind. Next, my current equation I'm going to write the current equation I as I is equals to Im sin Im sin omega t minus phi. Omega t minus phi. Now can anyone just tell me what is the value for phi here? What is the value for phi here?
0
Phi
only?
is in terms of value, you can say it is phi is negative. Phi is negative in nature. Getting my point? So I'll just indicate it is negative instead of writing NEGATV. I will indicate in the symbolic representation, putting a minus sign and BE. That is a negative. Okay. So I can write a negative like this. I will write negative like this. Okay. So my angle phi it is starting with the negative. See now you know that if angle phi is 0, where exactly the waveform it should start. But if my angle phi in the current it is negative in nature, it is negative in nature means my waveform it should start from a negative direction, right? So when I draw the diagram, so this is my waveform. If I want to draw this, so I will just consider this is my em, that is it is for both em and im, both em and im, the current and the voltage I'm going to indicate in a single waveform, and this is nothing but your theta, or it can be even it is set as theta is equals to omega t, either it is in terms of degrees or it may be in terms of radians. Now, just by seeing this equation, just by seeing the first equation, you know that the phi angle phi is 0. So I am going to start my waveform exactly at, it is not just because of this 0. Whenever you have the phase angle difference is 0, then you are going to start exactly at the origin. So my waveform of the what is that current voltage I'm going to get like this. I'm going to get like this. This is a waveform of E. This is a waveform of E. Okay. Now next is the current. The current
Waveform.
is here. It is Im sine omega t minus 5. Should I start from here only? Should I start from here?
I'm down.
No, because this 5 is there. 5 is there. This 5 is
Negative.
in negative direction. So where I should start? I should start somewhere here. Okay. And this distance, whatever I am maintaining from here to here, no, this distance also it will be decided by the angle here. Here in general they have given it is 5. If they give some value, whether it is from 30 degree, 40 degree, 50 degree, then you are going to use that angle here and you are going to do that. That I am going to explain you in the problem, sir. Now in general, assume that my angle phi it is in negative direction, so I will start my waveform here. If I start my waveform here, as you know that always the amplitude of current it should be lesser than voltage, right? So I'm going to start here. So my waveform I'm going to get something like this. I think it's not exactly I'll be getting here when I'm drawing here. So, but it will be getting here. But now you can see at the origin, my current it is cutting here, but the voltage it is cutting here. Now, can you make a difference here from here to from 0 to this particular distance is nothing but my angle phi, which is negative in nature. Getting my point? Yes or no? So my voltage it is
Yes.
starting from the origin and it is going to maximum at this point exactly at pi by 2. Exactly at pi by 2. Right? But see the current where it is going to maximum? Somewhere here. Somewhere here. Right? And this angle it will be something else. Okay. No. Now my waveform it is as it is starting from the negative. So if I want to get the phase angle, what is my phase angle means always I should take a reference line. So my EM it is started here and IM it is started here. The difference between these is nothing but my phase angle. That is the difference in the phase angle. And as it is in negative, so it is said to be a lagging phase angle, lagging phase difference. If it is negative, you indicate it as lagging. If it is positive, you are going to indicate it as leading. Getting my
Leading.
point? So, see, this is a waveform. You can understand here, no? So, my IM, it is starting, EM, it is starting here. I'm going to complete my waveform. And see, IM, it is starting with minus thing. And I'm going to start from here. I will draw the waveform. I will draw the waveform. Now, what is the phase difference? You can have a difference here from 0 to the EM it is started 0. IM it is starting at some angle. So the difference between this is nothing but my phase angle. Either you can consider here or you can consider here or you can consider here. The angle remains same. The angle remains same. Even if you consider from 0 to this one or from pi to the next level or from 2 pi to the next level, the angle phi it will be same here. Getting my point? So whenever you see the phase angle phi is minus 20, minus 30, keep in your mind if it is minus means it is a lagging phase angle. It is a lagging phase angle and always you have to start from the negative direction. Getting my point? Okay, this is with respect to the negative phase angle or it can be said as your lagging phase angle. Now suppose if my phase angle is positive, see the waveform here. If my phase angle is positive means my equation here, I am going to maintain E is equals to M sin omega t. My phase angle is 0 only, but my current here I am going to indicate it as plus phi. If I indicate plus phi now, my waveform it will be something like this. See, as the EM is doesn't have a phase angle difference, so it will start from 0. It will go to this in this particular direction and it will come back to 0. Okay, 2 pi. And what is the current? Current it is starting with plus phi, no? So on the same reference line, you go a little bit up and start from here. If you are starting from here, means it is not the starting point. See, majority of the student do the mistake here. See, whatever I'm explaining now, it is a mistake. I don't follow the same thing. Just I wanted to tell you where exactly you're going to miss the concepts. Okay. So if I'm writing the waveform, see, I will write this is for theta, and this is this equation. It is for both EM and IM. This is EM and IM. Both it will be written in the same now. So for it is a phase angle 0 means I will start from here and I will write the waveform like this. I will write the waveform like this. Now for IM, majority students, what they will do, they will start with a positive only. Okay. Assume that if it is started positive means negative, somewhere it has been started here. It has been started here. My waveform has been started here. And now it will go nearly to the maximum and it should come down and it should go in this particular process. It should go in this particular process. But the students, what they will do now? What they will do, that I will indicate in the red color here. So they will start the waveform here. They will start the waveform here and they will draw like this. They will try to draw like this. And where is the concept? As I told you, the amplitude EM should be always greater than IM now. But here, see, they have started the waveform. They'll go for the peak and they'll come down. This is not the way of writing. If you are starting with the positive, means assume that already it has been in the in the previous thing. It has been started. So if you start from here, you should go little bit up maximum and you should come down here. So this is a way of representing the waveforms. Here you have started here and suddenly it goes to the maximum. Again it will come back to 0 and it will go in this direction. Now if you want to find out the phase difference, if I want to find out the phase difference between this and this, I can't measure from the vertical direction. Phase difference, it is indicated in the x-axis. So I will project it back in the dotted lines. I will project it back in the dotted lines and the difference between 0 to this particular point. See, this is nothing but my phase angle difference for a
Yes.
positive. This is a phase angle difference for positive. Getting my point? And even you can consider even here from pi to this one or from 2 pi to backside. Okay, the difference between these two is nothing but my phase angle difference. Getting my point or not? Yes? Any confusions? Any confusions? Any confusions?
Only the positive part can you explain, ma'am?
Positive one, nah? Okay. I think if I write in the paint and if I explain, that will be more understandable, I think, for you.
Yes, ma'am.
Yeah. See, for a positive phase angle, I'll take two equations, that is E is equals to Em sin omega t. Em sin omega t. Here my phase angle is 0. My phase angle is 0 here. Okay. Now I will take the next one equation with respect to the current. I is equals to Im sin omega t plus 5. And I'm telling you again and again, whenever you start using from now, you should speak in terms of lagging and leading power factor. Don't say in terms of positive and negative. Okay. So this waveform is your leading power factor. If leading power factor means leading power factor, I will tell you. Okay, don't be in a confusion. I have two more points to be added for this. I will add further. Okay. So my angle phi is positive here. My angle phi is positive. So if I write the waveform, if I want to write the waveform here, I will just write x-axis and y-axis. I will just write x-axis and y-axis. This is theta or omega t, and this will be Em or Im. Okay, this will be Em or Im. Okay. Now, if I want to write the equation, what is the waveform for voltage? So as you have a phase angle phi is 0 here, so I will start directly from here. I will start directly from here and I will write my waveform like this. I will write the waveform like this. I will write the waveform like this. Okay, this is a waveform for E. This is a waveform for Em. Okay, and now the current. If you see the current here, instead of sin omega t, you have plus 5. So for that particular, instead of starting at 0, see omega t, if you get only sin omega t, that is a standard equation. So you should start your equation exactly at origin. Now for that angle, for omega t, you have added one more angle, that is angle phi. So it is going to shift a little bit upper side from here. It will start, my current, it is going to start from here. And when it is starting from here, obviously the origin somewhere it is going to take place here. It will be taken place here. So the shifting of the phase angle is taking place means, so I'm going to draw my waveform like this. for the current. Like this I'm going to draw. It is not exactly matching us, so it should come somewhere something like this. It should come like this. Okay, don't consider this. Now
Ma'am,
this is
last question,
current.
ma'am.
Yeah,
Ma'am, when phi equal to positive, ma'am, then we
yeah,
say that current is leading the voltage, ma'am.
yeah. I'll come back to that sentence. That's what I told you. I have to say that two terminals, leading and lagging. I will come back to that. Exactly. It will be leading and lagging. I'll come back to that. But you should understand the waveforms first. So I'm just speaking in terms of positive and negative. Then I will come back to your leading and lagging. How exactly you are going to identify if two or three
Okay.
waveforms, if it is given, how exactly you are going to explain that. Okay. Now you have understood here, right? So I have the difference, that is plus pi you have shifted up, and now if I get the difference between these two, from here to here, this is nothing but angle phi. Or if I take even the difference from here to here, this is nothing but angle phi. This is said to be a positive, what is the difference, or a positive phase angle that has been added to your current, or it can also said as a leading phase angle. Leading phase angle. Okay. Now this point is understood for you. Now my point is, if my point is, if my if my voltage or the current, if my voltage or current, if the angle phi is 0 degree, if the angle phi is 0 degree means, then it is said to be a zero phase difference. A zero phase difference means always whenever we are drawing the phase angle or the waveform for current and voltage, if angle phi is 0 for both the current and the voltage, for both current and voltage the angle phi is 0, then it is said to be a zero phase angle. The zero phase angle. Okay. Suppose the second thing is, if my phase angle is what is that, plus positive with respect to the current. Okay, my phase angle is positive with respect to current means, okay, positive means always the current will be leading the voltage. The current will be leading the voltage. Leading means what? The current will be starting first and the voltage will start next. Leading means, lead means it will be the particular one, it will be moving first. At the starting point of the current, it will be first, and after some delay, the voltage is going to start. So the current is leading here. And the next one is, if it is negative. Okay, if it is negative, the phase angle is negative means, if it is negative means the current is lagging the voltage at an angle phi. The current is lagging at an voltage phi. Suppose if you want to explain this lagging and leading power factor, I will just take two voltages only. I will take one voltage is E1 and the other voltage is E2. Okay. When I am writing the equation, E1 will be, it is what is that, Em into sine omega t. Em into sine omega t. Oh, sorry, one second. Did anyone started with the recording? Someone has started. Thank you. Actually, I forgot, because the recording link has to be shared to the management. Okay. So Em into sine omega t. I will take this as my equation. Okay. And my second voltage is, instead of giving in terms of in terms of thing, I'm just explaining both in terms of voltages only. If I take a three phase system, so you will be having three voltages now. So I'm explaining there. So here again, my second equation will be Em into sine omega t plus phi. Omega t plus phi. Now can you just tell me the sentence how you are going to explain? Just by seeing these two, you know how to write the waveform. Okay. E1 will start exactly at origin. E2 will start at an angle phi in the positive direction. You know how to write the waveform. Now I want the sentence to be said. Like how we are going to differentiate E1 and
Ma'am,
E2.
it
Ma'am,
will
Yeah.
be
it's
like E2 is leading the
leading,
E1,
ma'am.
or E1 is lagging
E1
by
is
E2.
lagging E1, E2.
Either you should say in any one. Don't say both. Lagging and leading. Don't use both at a time. Either you should stick on to the lagging, or you should stick on to the leading point.
E2 is leading.
Take
Sir.
either
E2
E1 as
is leading,
reference or
ma'am.
E2
E2
as
is
reference.
leading point,
E2
ma'am.
is leading.
What?
E2 is leading,
E2
ma'am.
is leading, ma'am.
Yes, E2 is leading E1. So when I write the waveform here, see E1 will start exactly at the origin. E1 will start exactly at the origin. And E2, it is plus 5 you have now. Somewhere it will start
Positive.
here. Okay, I will write that. And when it is starting, the amplitude, it will be same. Why amplitude it will be same? Because both are my voltages, right? So this amplitude, it will be same for both. Getting my point? But this is a waveform. The first one is a waveform for E1, and the second one, this particular one, is the waveform for E2. See this E2. If I come back here and if I see the difference, the angle phi, it is maintained here. The angle phi has been maintained. But see the waveform here. If I take on the reference line, which waveform is arriving first? E2 is arriving first than E1. So hence you can say that E2 is leading the voltage E1. The voltage E2 is leading E1. Same way in the terms of current also. If it is in terms of lagging, now I will take one more example with the lagging for the current. Now I will just take one more example, that is I will take two currents. I is equals to Im sine omega t, and the second is I is equals to Im sine omega t minus 5. Now omega t minus 5. What is the sentence?
I2 is lagging I1.
Sorry, it is I1 and I2. Yes, it is I1 and I2. Yeah, I2
I2 is
is,
lagging.
yes,
I2
I2 is
I2 is
lagging the
lagging
current
I1.
I1. You can say that I2 is lagging current I1, right? So when I write the waveform, obviously lagging means the second,
Behind.
what is that? Lagging
Lagging.
means it will start late. Leading means it will start first, whatever the term. Now we are telling I2. I2 is lagging. I2 is lagging means I2 is going to start after I1. So when I write the equation for I1 here, I1, the current, it will start from the origin and it will wind up here because angle phi is 0 here. Now see this I2 is having minus 5. So if it is minus 5 means obviously it will start from here. So it will go maximum and it will come back in this particular direction and it will come up. So when I take a difference, between these is here, when I take a difference here, for the reference line only you should consider always. When you consider the reference line here, so I1 is started earlier and I2 it is starting after that. So initially I1 only started first. The waveform I1 started first. After some phase angle, the I2 it is starting up. Always you should consider within the zero reference line. Don't compare somewhere here. Okay. If I consider 2 points, I1 is starting first and I2 is starting next. So always I2, the current I2 is lagging at an angle phi with respect to I1. So this is about your lagging, leading, and zero. Any doubts?
No, ma'am.
Okay. Now I think one particular problem we have somewhere here. I'll just open that. Ah, take down this problem. See, whatever the theory point it is there now, whatever I'm explaining, that important point, all the things are. So if whatever the content you are supposed to write, what is the content? That you are supposed to write in a point, they have given this in here. And even the notes which I have shared, even there it is there. You can write, you can prepare what is to be written. But now my aim is to understand, make you to understand the concept, and you have to remove the concept what you have used to do in the PUC. In PUC, in the plus 2, what they are going to do, they are going to make you to put that question into your head and the concept, and even what are the contents to be written, how you should write, and what are the points to be written. Everything they used to put it in your brains. But here in the engineering, we are going to give you the idea, we are going to make you to understand the concept. The next 60% you have to prepare. you have to prepare and you should keep what all the things we are telling now. You have to keep in mind and you have to